Hi everyone, today I'm going to tell you about a problem that every large tech company faces when building AI systems and the solution we built to fix it automatically using the deep learning. Let's start with a real scenario. Imagine you work at a company like Google and Amazon. You have hundreds of teams: HR, legal, finance, engineering, and every team want to build an AI assistant that can answer questions from their own internal documents. This type of AI system is called RAG, Retrieval Augmented Generation. The idea is simple. You upload your documents and the AI finds right information and answers for your questions. But here is a catch. To build a good RAG system, you need to make several technical decisions: how to split your document, which search method to use, how to retrieve the information. These decisions are called configurations, and every single team has to figure out this out from scratch. The HR team makes one choice, and the legal team makes a different choice, and the engineering team makes yet another choice. No one knows which choice is correct. The result is wasted weeks of engineering and inconsistent quality across the teams, and teams without technical expertise simply cannot build these systems at all. So, what exists today to solve this problem? LangChain and Llama Index are the popular tools, but they are like giving someone a box of Lego pieces with no instruction. You still have to figure out everything yourself. There's a research tool that automatically searches for the best configuration, but it requires you first create thousands of question and answer pairs manually. Most teams don't have weeks to do that. Another research system called Metis fine tunes your rack pipeline while it's running, but you need a fully working system first. It can't help teams who are starting out. Commercial options like Azure and Amazon cost thousands of dollars a month and lock you into their ecosystem forever. The common problem with all these: none of them can simply look at your documents and tell you upfront before you build anything which configuration will work best. That's the exact gap we fill. So here is our idea: AutoRAG. Think of it like a doctor diagnosing the patient. Before prescribing treatment, the doctor examines the patient, their age, symptoms, medical history. Based on those characteristics, the doctor recommends the right treatment. AutoRAG does the same thing for the documents. It examines your document collection, how long they are, how complex is the vocabulary, what domain are they from, and based on those characteristics, it automatically recommends the best RAG configuration. We do this in three phases. First, we build a training dataset by testing 12 different configurations across 950 enterprise documents and recording which configuration worked best for each document. Second, this is our core contribution. We trained a neural network model called MLP that learned the relationship between the document characteristics and the best configuration. Third, when a new team uploads their document, our system examines documents and run the neural network and predicts the optimal configuration. Let me explain how the neural network actually works. For every document collection, we extract 391 numbers that describe it. 7 of these are the simple measurements. Things like average sentence length, vocabulary density, how many bullet points the document contains. The most important measurement is a 384-dimensional semantic embedding generated by a model called SentenceBird. Think of this as a mathematical fingerprint that captures the overall meaning and the style of your document collection. These 391 numbers go into our neural network, which has an input layer of 391 units, two hidden layers of 64 and 32 units, and an output layer of 12 units, one of each possible configuration. The network outputs which configuration it predicts best for the given documents. To train our neural network, we built a dataset of 950 enterprise documents across 5 real-world domains: HR policies, technical documentation, financial reports, legal documents, and general business content. For each document, we wrote 10 question-answer pairs and ran all 12 configurations to measure which one retrieves the correct answers out of most accurately. This gave us 950 labeled examples, each one telling us which configuration works best for the type of the document. Now, let's look at the results. We compared our MLP neural network against 6 traditional machine learning approaches: random forest, SVM, gradient boosting, and others. The baseline, which is always guessing the most common configuration, gets 18% accuracy. That's like flipping a coin and being wrong most of the time. Our MLP achieves 47.37 accuracy, more than 2.5 times better than the random guessing and better than every single traditional approach we tested. Why does our neural network win? Because with 950 documents, it has enough data to learn complex non-linear patterns between the document characteristics and the optimal configuration. Breaking down the results by the document type, Legal documents are the easiest to predict at 52.63%, likely because legal texts are very distinctive vocabulary and a rigid structure that clearly signals which configuration works best. Technical documents is the hardest at 43.68% because the technical writing spans a huge range of styles from API references to architecture documents, making it harder to predict. Overall system achieves a 47.37 accuracy across all the 5 domains. But prediction accuracy is only half of the story. The real question is, does using our predicted configuration actually makes the rack system better in practice? We tested 3 scenarios on 95 documents our model had never seen. First, the default configuration that any team would use without guidance achieved 41.30% retrieval precision. That means the AI found the right answers only 41% of time. Second, using our MLP predicted configuration, jump to 68.40. That's a percentage 27 point improvement. The AI now answers correctly more than two-thirds of the times. Third, the Oracle, which is absolute best configuration found by testing all 12 options exhaustively, achieved 74.80. Our predicted configuration is only 6.4% points away from the perfect and it gets under there. To summarize, AutoRAG makes three key contributions. First, we proved that the document features contain real signal for predicting the RAG configuration, with a 57.78 average gap between the best and the worst configurations. The choice genuinely matters. Second, our MLP achieves 47.37% accuracy, 29 percentage points above the guessing, outperforming every traditional approach. Third, and most importantly, using our predicted configuration improves our real retrieval quality by 27% over the default, approaching within 6.4% of exhaustive search in under 1 second. AutoRAG means any team, regardless of technical expertise, can build a high quality rack system automatically. Thank you.